Okay, great. So you should see my slides. And I'm glad to have you all here today for this webinar. We'll speak about RayXpert, we'll speak about Monte Carlo simulation and those calculations on nuclear medicine, and with a focus on hot cell design, integration, and dose calculation. And I'm João Martin, I'm a business engineer for the company TRAD. Here on my left, you have Leo Novak, which is a nuclear engineer.
Nice to meet you.
And I'm really glad also, I'm really excited because we won't present alone today. We are co-presenting with the company eSolutions, which is a customer of TRAD and a user of RayXpert. So we are really glad to have Eric today to present their work with RayXpert. Eric, if you want to quickly unmute yourself and present you.
Sorry, yep, I hit it on the button instead of on the computer. Hi, I'm Eric Petrus. I'm a CAD design engineer over at eSolutions, and I'm just excited to be here today and get to talk about how we use their product to help our business.
Thank you very much, Eric. That's very nice. So yeah, as I said, feel free to ask questions, and well as detailed, this webinar is being recorded. So before we get started, if I can switch my slides. Here is a summary of the event. So we'll start with a quick introduction of RayXpert. Then we'll present you with Leo a model we designed together of a glove box inside the facility and dose calculation using RayXpert. Then we'll quickly present who is TRAD, what is the company, and what do we do here. And finally, I will leave the floor to Eric and eSolutions to present their work with RayXpert. So to start, for those who are not familiar with RayXpert, it's a software that combines 3D modeling, as you can see here, and a computer calculation code using the Monte Carlo method. The final goal is to simulate gamma, beta, and neutron sources. And we are proud to announce that with the next release in 2025, there will be available protons, deuterons, alpha particles, and ions. The main use case for RayXpert is shielding design and radiation protection studies. But of course, you are free to be creative. If you have other products and you feel the software could be useful, feel free to contact us. Today, we have more than 80 companies and 300 users around the world. And a huge functionality and interest of RayXpert is that you can import a CAD model that has been designed in another software. If we go deeper in the main features of the software, you have libraries of materials and radio materials included directly in the software. So you can design your sources of radioisotopes and beams. You can work with several sources and not only a single one, and you work also with multiple detectors. You have dosimetry coefficients included, time decay. You can automate some actions with a scripting console. You have distributed calculation, which is really important today. And finally, you have neutrons based on these two libraries with this range of energy. So this was a really quick introduction just to get you to know the software. And now we'll start with our model with Leo. So here is the final result we want to present you today. As you can see, we have a model here that Leo will detail just later. And you can see a dose mapping here of the radiations. You have a continuous color scale with the units here and the range of the values. And it's really interesting because you can see here, we can, thanks to this mapping, design the walls, design the shielding everywhere, choose our materials and choose the thickness of the walls and the materials. So we have the shielding we want at the end. So this is the final results, but how did we achieve it? Let's start with the basics. Here, as I said earlier, you have an interactive 3D window, so you can see what you are modeling. You have buttons to create elementary shapes like a box, a cylinder, cones, spheres, anything you want. And you have some tools to visualize what you are doing in the window. You have here options to manage your materials and radio materials, but we'll talk about this a bit later. Here you have the structure of all your model, so you can see all the elements. You can organize them in folders, so it's quite understandable for you. Here, every time you click on a structure on an element of a structure, you have the details of the name. You can set up some nodes. You can choose the material, apply a transformation. You have a big range of options. This model, Leo did it himself, but you can also import a CAD file at the step format. Here is an example. You can see here you have quite a complex geometry. For the short story, this is the E-beam source we have here at TRAD. because we have a bunker next to me that we use for radiation tests. So this model has been provided by the supplier who we bought the machine, and we use this model to design our bunker some years ago. So we use RayXpert to design our own bunker, and thanks to this complex geometry, we have been able to do it. So now, if we dive into the software, oops, sorry, just quick misclick here. So here I will let Leo play around the model and explain to you what he did.
Hello everyone. So I'm going to present you more in detail the model that Joao presented to you just before. So to your information, it's a part of a real hospital in France, okay, in Albi, if you want to know. So what I wanted to model. So firstly, the unboxing box. So when different radioactive sources arrive in an hospital, they are in a shield, okay? So as you can see here, you got, oh, excuse me. As you can see right there, you have different shielding, and inside those shieldings, you can find some source. And basic sources in the hospital are, for example, 18 fluor or stuff like that, okay? So in order to unbox those radioactive sources, I modeled a gloving box, okay? So it's a simplified model, but here you got, you can see, as Joao said just before, on the left, all the information about the materials, okay? And in the tree structure, you have access to all the basic shapes, excuse me, which I was able to model all these stuffs. So here you got the gloving box with glass and lid, and inside this glove box, here you got a radioactive source inside the shielding. You will be able to see the source right there. And once the source is out of the shieldings, the different patients, the radioactive source is put into the patient because we are in a hospital. So here I wanted to present a TEP room, so tomography emission positrons. So here you can find the different rooms where the radioactive source are injected inside the patient. It's the roof. Here you got so the treatment room, okay, and when the treatment is over, the patient have to go to the toilet in order to evacuate the radioactive source. So how I built this model, thanks to basic shapes, like Joe just said before. For example, the walls are just here boxes, okay, and you can set here the different dimensions, okay. And we will present you the radioactive source a little bit later. So you can go ahead.
Thank you, Leo. Great introduction to the next part of my slides here from window here. Here we can speak about radio materials. So when you finish modeling your facility, equipment, anything, you want to start setting up your sources, your radioactive sources. The first step is to choose your radio materials. You have many ways to do it. First of all, you have integrated libraries that are inside RayXpert. You can have the references here that help you describe your sources. You can choose the chemical elements you want. You can choose the isotope, and you can choose the percent of activity. You can set up a date for the time decay, so you have all the information. Or you can import a text file with all the information inside if you want to have a mix, or you can even set up the mix yourself. For example, this one I did it with 18 fluor, etc., etc. Then when you have created your materials, you want to assign them to specific shapes in the model to create sources. Here, as Leo said, he created spheres to represent the radioactive sources, and he assigned the materials I showed just before to each of these ones. So you can see here you have a source of 18 fluor, etc., etc. So if we go back to the model, just so Leo can present you here how he did with the sources.
Yes, so when the geometry of the model is over, you have to set the different sources. So here you firstly go on the Monte Carlo computation mode, and here you got 3 different menu, and the first menu that we are going to present you is the source menu. So here you got the different source present in this model. So for example, let's take for example the 18 fluor. So if you want to set 18 fluor sources, so you just have to create your radio material. Okay, right there. Here you can pick up the good radioisotope and select the good atomic number. Okay. After that, when the radioisotope is present in this list, you can select it in this list. When it's over, you have to set which rays of the radioisotope, which particles and which rays you want to emit. So in order to do that, we have two ways to set this, the standard mode and the advanced mode. With the advanced mode, you can directly select the rays that you want to take into account. And with the standard mode, it's pretty the same thing, but you set an emission rate. Thanks to this emission rate, you will be able to select the rays that you want to take into account. Here, I just want to take into account the X or the gamma rate, because in radio protection issues, excuse me, we don't take into account the electrons, but we are more focused on X and gamma. Okay, and for the fluor 18, it's the rate of interest. Is the 518 kV rate. And here you got different configuration isotropic, so where the rays are going to be emitted and from where. Here I select the node, so I create a sphere here in the middle of the room, and I just assign to this sphere the source, and all the rays are going to be emitted from this sphere. And the final step is to set the activity of the source.
Thank you, Leo. Now, if I go back to my slides here, the following point is that when you have your model and your sources, you want to start your calculation. You have two ways to parameter it. The first is you can create what we call a sensitive element. Here, the example can be quite clear. You have a sphere that is a sensitive element. This sphere is made of water and can easily represent the head of somebody. If you imagine a context, you are in a hospital, you have a treatment room, and you have somebody walking in the corridor next to it. You want to be sure that this person will not get a dose from the treatment room. So the best way to simulate it, is to create a sphere in the corridor and see when you simulate if there is dose touching this sphere at the end of the calculation. That's the first way. The second way, if you want a more general calculation, you can do it over your whole model. So you create a 3D mesh, which you can see here, and I will let Leo present it later. You have a 3D mesh, and you can then create a 3D mapping with a color map that we just saw earlier. So I will just let Leo speak some words on this.
Okay, thank you, João. So now our model, the geometry of the model is over. Our source are setting. So the final step is to set the sensitive elements of the mappings. So for the sensitive elements, you go in this menu, and in this example, there is no sensitive elements physical. We just set 3D mapping, but if you want, I don't know the doses in this world, you just check here the world that you want to analyze, and here in the configuration set, you choose the quantity that you want to compute. Okay, so let's be focused more on the 3D mapping. So here, often in radiation protection studies, the customer wants to know a general dose distribution in his hospital, for example, right there, because he wanted to be sure that all the doses criteria are respected. Okay, so in order to know that, I set 3D mapping that cover all the area of the model, and here you can find the different setting in order to set your 3D mapping. So here is the center of the 3D mapping. Okay, so the position here is the center of the Cartesian mapping. So Cartesian is a rectangular mapping, basically. You can see more details right there. Maybe I'm going to lower the resolution. We are going to see this just after. Don't worry. And okay. And, okay, here you can see all the area covered by the 3D mapping. Okay, so the center of the mapping, as I said just before, is right there, and this dimension are here to set the accuracy of your 3D mapping. Okay, if you want bigger or lower resolution on your 3D mappings. Here, for example, I don't know, we just have to make the computation, but for example, here, the length on one mesh along the x-axis is 2000 divided by 20. Okay. If you have some question, don't hesitate to ask in the chat. Okay. So here, when the center of the 3D mapping is set and the resolution is set, here these three parameters are here to set the resolution. You are able to launch your calculation and know the distribution of the dose in your hospital.
Exactly. Thank you, Leo. Quick switch on my slides. As Leo just said, when you have set up your mapping, your mesh, you are ready to launch the calculation. The final result of the calculation, in our case, is a 3D mapping with a color map. You saw an example of this one at the start with the color scale, etc., etc. And you have different ways to visualize it. You can do something continuous. You can do it by voxels, and you have the detail for each voxel, sorry. And you can also set up what we call a zoning. A zoning is a discrete scale here that corresponds to your requirements in your country. For example, here in France, we have requirements of doses to respect in order to be sure that we are in a safe zone. Here, the zoning you can see is a French zoning. If you are in the white zone, you are safe. If you are in the blue zone, depends on the requirements of the project considered. So it's really important and really visual. If you want to present something to an institution, to a customer, you can ensure that your shielding that you have been doing in RayXpert respects the requirements. We'll quickly speak about this 3D mapping and zoning here.
Okay, thank you, Joao. So as Joao just said, you have different ways to visualize your 3D mapping. So the first is a texture mode. Okay, so you can set the opacity of the texture just right there. Okay, so it's in order to have a general view of your 3D mapping. But if you want to know your dose distribution at different slice, if you want a slice view, you can also do that. For example, following the z-axis, right there, you can see right there that following z, you can choose the height of your slice, okay, and you can do it following the two other axes, okay. For example, here following y, and here following x, okay. So if you want to focus more the analysis of a part of a model, you can easily use this kind of visualization, okay? So the voxel is pretty the same thing that the texture mode that we just did before. It's in order to have a global view of the model, okay? So it's right there. And as Joao said, you can also, I'm going to adapt this view. As Joao said, you can do set zoning. Okay, so here, as Joao said just before, it's the French zoning. Okay, so maybe in English it's not exactly the same value on the right, but if you want to set your own zoning, your personal zoning, it's totally possible. So you just click here on the red button, add. So here you are, I don't know, we can name this English zoning. Keyword, so here, generally, when we talk about zoning, the quantity that we want to estimate is the DAD, the H*10, data type those. And here you can set all the different values. For example, here I can set, it's an example, it's not really the English zoning, but it's just in order to give you an idea. And here we to put 100. Okay. So here I just set the different doses intervals. Okay, and here you can use the color that you want. So for the lower dose, we are going to make blue. Here we can make, for example, pink. Here maybe red, and for the final black. Okay, so you it's two times the same thing. Okay, so here you set your own zoning with your own zone when you open those, excuse me. And when your zoning is set, it is available in the list right there. And as you can see here, you got the zoning that I just set. So it was just an example, so the value are not accurate, but it's in order just to show you.
Thank you, Leo. If I go back one last time to my slides. So we are at the end of the model. So you have seen how we built the model, how we set up the sources, parameterized the calculation, and what is the final result. Just a few words about TRAD before letting Eric from eSolutions speak. So we at TRAD, we do not only develop softwares. Of course, we develop RayXpert, but we also developed FastTRAD for space and Omer also for space. We do radiation tests on in our laboratories, so to test materials, components to radiations. And we can also certify some electronic components for customers to be resistant to some radiations. You can have more details on the website here if you are interested. And now it's up to Eric from eSolutions to present. I will stop sharing my screen. It's up to you to show us what you prepared, and thank you once again for speaking today.
Of course, thank you for having me. Like he had mentioned, I'm Eric Petrus from eSolutions, and I'm going to talk a bit about how we use RayXpert to help build our products. First, I'll talk a little bit about our company. So we create basically everything that would be in a radio medical facility except for the cyclotron. So this would include hot cells, SCCs, isolators, LAF hoods, the actual clean rooms themselves, and we also do network integration. A little detail about the hot cell. I'm sure most of you know what these are, but for this unit, it would be a user stands in front and uses the telemanipulator arms to work on whatever isotope or tests that they're running inside of the unit. We can do variable lead thickness, so depending on what isotopes you're actually working on and what shielding requirements you have, we can adapt to that. We also make shielded mini cells, which are very similar, but these are really good in pharmacy situations since they are a bit smaller. We offer the single or double stacked. We also have hoods and isolators. What you're seeing is a LAF hood, laminar airflow hood, and we're going to talk about an isolator later on in our presentation. We can also do mobile shielding doors. So for lead vaults, we can make doors that are actually movable, so that way people don't have to be there to actually move the doors themselves. And then we also make the clean rooms themselves. One of our big things is that our walls are removable. So if you need to move in equipment or move out equipment, you can actually take down some walls, bring the equipment in and out, and put it back up. We also offer shielded walls as well as leaded glass in the walls. And here's a overview of one of our facilities. As you can see, it's got 28 different hot cells and isolators inside of it. It's quite a big facility. And here's some pictures inside of one. But what we're really here to talk about is how we use RayXpert for us. So the first example I'm going to go over is a SCC, or shielded containment cell. So what you're seeing here is what we would actually model. For us, we use Inventor. And like he had mentioned earlier, you can import step files. So that's what we do. But first, we strip it down to a lead-only version. So it only has the lead, the leaded glass, and an inner cell. This gives us a most basic version, and it puts less strain on the simulation itself, not having all the structural materials in there. And then when we put it into RayXpert, you actually get this view down at the bottom right. I personally like to keep it in wireframe just so I can see everything that's going on inside. But for these specific tests, we were looking at the efficacy of a new door design. So here we have some images of the results. We like to use the slices that he mentioned earlier, along with our custom zoning tree. These are just a few of the increments that we like to use. They're pretty common for customer requests when they're trying to keep it under a certain dosage rate at certain areas. And we also do sensitive elements at specific locations, such as if the operator is leaning up against the window, if they're standing back at a working distance, what type of dosages they would be getting at those distances. We got a few more views of them, as you can see where the source would be right in the middle in that dark blue spot. And according to this picture, that door is working quite well at keeping all the radiation away from our user. And here you can see some of the results from this. It may look like the window is bad because it's got this really bad sigma, but that's just because it wasn't getting much data, so it thought there was an error. But as the heat maps show, there's just no radiation that's even touching that detector that would be in that position. A second example is we also do this with our isolators, which are very similar to the LAF hoods. The isolators, they typically just have thinner shielding than an SCC. They're smaller. And again, we have these in different styles, different lead thicknesses. But you can see where the source is again with our custom zoning. And you can see that all the results are looking good. It's white outside, which according to this is very, very low dosages. Again, we've got some results from the detectors that we place throughout at head, knees, and at a window. But those are more of the complex simulations that we run. We would typically run those for about 24 hours. But we also can use RayXpert to do much more simple simulations. So for this one, we were just looking at testing some lead glass. For the specific one, we were looking at multiple panes of glass versus one pane of equivalent thickness. And on this test, actually, didn't even bother showing the results from it because it was zeros across the board. So it meant that we had plenty of shielding on those windows. And then we have a list of a few of our customers that we've worked with currently and in the past.
Thank you a lot, eSolutions, for being here today. It's really great and precious for us to have you, to have this kind of interaction with you, and to see how you work, and that you're satisfied with RayXpert as well. It's important for us to know that that our work is used in good ways with customers around the world. So thank you for that, honestly. And I hope we will be pleased to announce some webinars in the future again. So if we can have new topics, or if some of you have topics you would like to discuss, feel free to contact us again. We will be pleased to see you again around in a conference or around a webinar. So thank you once again very much, and see you soon.
Goodbye.